Hi, and welcome back to this module on ensemble modeling. As we saw in the last video, ensembling is nothing but the technique to combine several individual predictive models to come up with a final predictive model. So in the example which we discussed, M1 to Mn were individual models which were giving predictions 1 to prediction n respectively, and we combined them to come up with a single model. Now the question is, how do we do this combination? And there are several techniques to do this, and this is where the art of ensembling comes into picture. So let's start by understanding some of these basic techniques. And in order to understand them, the example which I'll be using is the Titanic survival example. So if you remember, we saw this example previously in this course, where we had details about individual passengers who were traveling on Titanic, and we had to predict which customer would survive the Titanic tragedy. So let's start this process. So let's say we have three models, M1, M2, and M3, which are based on different techniques. So M1 could be based on a logistic regression, M2 could be based on k nearest neighbors, and so on and so forth. So let's say there are these three models which are giving us three different outcomes. So this table shows you different outcomes from each of these two models. So what this means is model 1 says that the passenger with passenger ID 1 did not survive the Titanic tragedy, whereas model 2 says he or she survived. And model 3 again says that the passenger did not survive. So let's say these three models have their individual predictions, and we want to combine them to come up with final prediction. So how do you do that? Well, the simplest technique is to just take final outcomes from each of these models and take the maximum voting of each of them. So what do I mean by maximum voting? Well, whatever my models tell me the most is what I'll go ahead with. So going back to the car analogy, if I want to choose between, let's say, model A and model B, if multiple people are recommending me model A over model B, I'll go with model A. So the same rule applies here. If more models are telling me that a passenger would survive, I will consider the passenger as survived. Whereas if more models are telling me that the passenger did not survive, I'll predict that the passenger did not survive. So here in this case, so for example, passenger 1, 2 of my models said that the passenger would not survive. So my final prediction is 0. On the other hand, in passenger ID 2, since model 2 and model 3 were saying that the passenger would survive, I'll make my final prediction as 1. Right? So max voting is the way in which I take the outcome from individual models and just take a vote. Now this cannot apply for a regression problem, where I have to actually predict a continuous variable. So what do you do in this case? Well, in order to do this, let's actually go through the example. So again, let's have three different models, M1, M2, and M3, which are giving me individual predictions. And what I need to do is make the final prediction. And the nearest analogy I can have with max voting is average. So I'll just take average of whatever my individual models are telling. So in this particular example, for row 0, I get an average of 3466.66. So that would be my prediction. Now, if you think about it, what I'm doing is I'm not taking into consideration the accuracy of individual models. I'm giving each of these models equal weight, which is not a very prudent strategy, because if I know that a model is performing better, I would want to give it higher weightage. Right? So going back to the car example, if I know that a person has more knowledge about cars, I would like to give his or her recommendation a higher weightage. So coming back, let's say that these three models, M1, M2, and M3, have a R-square on validation of 0.6, 0.4, and 0.7 respectively. So what does that mean? That means that model 2 is not performing great as compared to model 1 and model 3. Right? So model 3 is my best model. Model 2 is my worst model. Now, if I have to somehow combine them more intelligently, what I can do is I can give them some sort of weights. And these weights would be representative of how much weightage do I give to their predictions. So since in this particular case, my model 2 is not the best model, I'll give it a lower weight, whereas model 1 and model 3 are better models, so I'll give them higher weights. So let's say I give them weights of 1 and 2. What I would do now is I'll basically multiply these weights to individual predictions and then take their mean. So model 1 predictions, which are 3,900, 390, so on and so forth, I multiply it by a factor of 2. Similarly, I multiply model 2 by a factor of 1. So no values change there. And model 3, I multiply by a factor of 2 again. And now I take average of all of these by dividing it by 5. So what I've done is I've taken weighted average from these models, but the weights were decided by me. That should give me better result, right? Because I understand that these models were better and I've given them more weightage. Now, is there any other way to do it? Instead of me deciding how much weight to give to each model? And that is where a rank averaging comes into play. So what I do is I give ranks to individual models. So a quick thing to remember over here is that I'm giving rank 1 to my worst performing model, right? So rank 1 is the model which performs the least, rank 2 is the next best model, and rank 3 is the next best model. So I give these ranks to each of these models, and then I take weights from these rank. So I basically sum up these ranks and divide each of these ranks by that total value. So my weight for model 2 comes down to 1 divided by 6, which is sum of the 3 ranks. Right? So similarly, I come up with weights for each of these models, and then I multiply those weights by individual models. So 3,900 gets multiplied by 0.33. Similarly, model 2 and model 3 are multiplied by 0.16 and 0.5 respectively. And then I just take sum of all of these values. Now, remember, I don't need to divide because this is not mean. I've already done the normalization at time of taking weights. So I just need to sum them up, and this is what I get as the final outcome. And this is rank averaging, right? So just to summarize, so there are various techniques which we saw which can be used to combine the results of these models, starting from max voting. Then we looked at averaging, weighted averaging, and rank averaging. And using these techniques, we can cover classification models as well as regression models. In the next video, we'll apply these techniques to a problem and show you how they work in a particular case. Thank you.